All right, so I wanted to talk to you guys about the SciShow episodes and the Neil Tyson deGrasse and just about all of the the Star Talk and all of the channels shows recently that have been focused on one main point. No matter what they're touching on, having to do with whether it's gravity, like Neil and Joe Rogan just discussed in the last presentation of all of our great minds thinking about what's the next steps, what we can do. SciShow presenting where we're at and what the next steps of man is going to do, and all of these things that they're talking about on these channels. There's one underlining message they're trying to pump into your brains, and that is to make you think one thing. It's not worth it. Just like the moon. We can't go because we don't wanna, that's all. It's just not worth it. There's nothing there. I mean, it's so expensive, and I mean, God, who wants to do that anyways? And it's so hard. I mean, don't even bother. Why? It's not worth it. And that's the underlining message. All of it. Look at my previous episode that I just posted with Neil Tyson deGrasse, talking to Neil deGrasse Tyson, whatever his name is, talking with Joe Rogan, and you'll find that the video ends with them simply stating, Neil simply stating, stop asking why. It's not worth it. Look, shut up. We put a probe on the other planets. We put a probe on Mars because we can. And they'll talk about why they can put one on Mars but not on Venus, as they try to talk about it later. And it's simply because, and we'll touch on this again, we can fake Mars. It's the Atacama Desert. It's really easy. It's down there in Chile. We can't fake Venus. There's no way that we can make anything presentable today that will make it possible for people to be like, dude, that's not Venus, or legitimately that's Venus. Like, it won't work. They will end up screwing up their own agenda. So they're not going to. For the same reason, the new, the space dune buggies bouncing all over Brad Pitt's new movie. The reason why they're using that and having it with the terrible Boston Baked Beans commercial style graphics is they're dumbing the graphics down so that if they have to present something for the Artemis mission that shows, see, we're out there, we're doing it. If we have shitty graphics now, then there won't be a discussion of whether or not, we could do it, and whether or not the videos that Hollywood's putting out are better. That's why Stanley had to pump out the Space Odyssey and a bunch of crap like that looked terrible, so that when we faked it with, the Apollo footage, it would look more realistic than the science fiction that was Hollywood. So really hard to make anything about Mars now because Matt Damon he's been to Mars, hasn't he? And there's all those pictures to prove it. So with the sense of, see, I've got a picture, we've been there. Now that we can make anything, the deep fake is so good that anyone can be anyone now, make anyone say or do anything. It's kind of hard to fake this, so bottom line, we're not even going to try. We're just going to change the agenda to, why care? Why even ask? Why care about gravity? Look, see, don't you like these videos? Why think about it past where we've come to? That's Neil's stance. That's the astrophysicist who speaks for America. So, obviously, they're going to have something to say similar. I'd like to touch base on it.
Venus is sometimes referred to as Earth's sister planet. It's close by and pretty similar in size. It's thought to have been fairly Earth-like early in its history. Once upon a time, it may have had lots of nice shallow seas, a great place to form life. But it's not so nice to visit anymore. A runaway greenhouse effect caused Venus to undergo massive, rapid climate change, boiling off the seas and transforming it from what may have been a pleasant, beachy planet into a desolate nightmare, complete with sulfuric acid rain. Earth's got a bit of a greenhouse effect problem too, so it seems like studying Venus could help us understand both our past and our future. Too bad, because Venus is so awful, sending missions there just isn't worth it. So we know
Alright, so that's where it starts, right there. First off, they are touching on simple theories given to us and proven true for over 100 years now. We've had basic relativity, we've had these things like expansion in our vocabulary for a great amount of time, and yet we don't really contemplate what that means. The sun is expanding. Well, we're entwined with its magnetospheric bands. We know that those magnetospheric bands cause and affect great amounts of our magnetospheric bands to act a certain way. So if it's expanding and it's changing its bands abilities to manipulate ours, then our bands inevitably will change. Obviously, Mercury didn't stand a fucking chance, and gone. It's just, in theory, it should be like gold and diamonds at this point, and platinum. It should just be a big ball of precious metals. And so, if anything's worth it, if we want to talk about mining asteroids and mining, and this, solar energetic particles and all of the mass and light from the sun have no effect on us at all. It's just, as long as we've got some tinfoil around us, like NASA's fucking says, this passive shielding will work fine. We don't need active shielding. Except for the Earth needs active shielding, we need it to be on it, and except for when we leave it, we don't need it. So, but never mind all of that. So, Mercury, can't get to it, too hot, or too not worth it, even though it could be totally worth it. So we'll talk about Venus instead. The fact that Venus, the next one out, losing its magnetosphere because the band's changing, or intensifying its magnetosphere because the bands are changing, we don't know, because man, it's just not worth it. Only those Ruskies ever got down there and checked that out, which they'll touch on in a second. Again, Russia always did it first, even though I thought we were bankrupting them. I thought they were toast. We had that awesome fucking airplane that could touch, their space station, or at least go close to it, and we were so awesome because of that. They were just shit, except for they did all of this. Anyways, they'll touch on that in a minute. So Venus clearly has something, with expansion affecting its magnetospheric bands, causing the runaway greenhouse effect. Something that we're starting to experience. Anomalies and strange things happening to our magnetospheric bands we can't seem to figure out. Not only can we not figure out what the magnetosphere is or why it's there, we say iron core, but then we look around at the rest of the solar system and that doesn't match up. Things don't require that. However, and when they have it, and they, theoretically, if Uranus or Neptune actually do have an iron core, even though watch sideshows or any of their things, talking about Neptune that they just put out, and they just call it rocky and icy. They don't talk about the compositions of metal, So is it a transitional metal? Is it a nickel, or is it just rock? Is it just a carbon base? See, now that would give a completely different polarity points. So there would be or would not be a magnetosphere caused from it, unless it's just rocky and icy, They're not descript for a fucking reason. That's why, because magnetospheric bands aren't caused from the molten cores of specific bodies. They are either already there, or an anomaly we just can't even fathom. So, Venus is expanding, or is dealing with expansion of the sun, and is now, a runaway greenhouse effect, and we're starting to experience it, as he just said. So clearly, there is something we can learn about this expansion. So Mars never was. Take that in. Fuck what they're saying and what their theoretical ideas, because they're all just looking through telescopes. Note that just, was it yesterday, they discovered a new landslide in the North Pole of Mars. It's from a telescope here on Earth. It's interesting that Arizona's university and their telescope systems reported it, or at least they are the ones that are doing the study or reporting the study. So clearly it's government-based. It's an educational system that is for the entirety of the human species, but it's run by the government, and it's stationed at the government, and the government releases what we need to know about it. So they're going to call it the Mars, the Mars rover. That's kind of like our LRO. It's the MRO, and it's taking those pictures. When bullshit, it's a telescope here on Earth. Or if it's infrared light, then it's the Hubble. That's it. We're losing the Spitzer and the Kepler, and so the Hubble's kind of our last bet. That's why we're making the James Webb. I digress. So, anyways, with the expansion of Venus and the inevitability that that will be us soon, that's why we're looking to Mars and not towards Venus, because inevitably we can't go there. Russia used probes, and that was, again, like our probes, telescopes. However, when they were launching telescopes into the upper atmosphere, before we ever got to it in the 90s, because they did it in the 70s and the 80s, and that's how they were looking at all of this, is their probes, their systems to measure in radio or in infrared lights, and these various systems that they would just launch up into the thermosphere, deep within the thermosphere. Before we started doing heliophysics satellites and discovering what it is we're working on and working with today, they were doing it back then. They've gave us the ideas as to why we have to stop at 2:30 and why they did and why everybody has to, period. And so while they were looking, they found, the best, information we have on Venus, and they'll touch on that here in a few with the different types of missions. But one of the missions that it needs to be acknowledged is the missions that they say lasted over 30 minutes on the surface. That's proof it wasn't a telescope, or it was a telescope and it wasn't. That's proof it was a telescope because, well, bottom line, let's take the automotive field and that department, that era of time, I should say. How do bus fuses hold up at that temperature, let alone that pressure? Just basic bus fuses. That's what we were using at the time. Anyone who's worked in the automotive fields, or anyone who's worked in any of the general contracting fields for any of the major commercial buildings. What else did we have? The military, this bankrupted Soviet Union had more advanced technology than the great American manufacturing system of the mid-70s? I don't fucking think so. That was the highlight of our days. That was the last hurrah of American manufacturing. So, bullshit. We had the better stuff. We claimed them. So, they didn't go there. We got glimpses in. And that's why basically there's no pictures from any of our larger telescopes or any of our systems of Venus that is looking into and through. When you Google it, you just get vague shots, almost everything CGI. It's because, the agenda is now, it's not worth it. Because bottom line, with the idea and the theory of expansion being the inevitable, can't bust it, us sitting here watching the greenhouse effect run away just like Venus is, and the people that are starting to go, we need to be studying Venus to understand what this greenhouse effect is and how we might be able to combat rising CO2 and carbon dioxide rates. So what is the next step? How can we do this? And this is the planet to look to. However, why aren't we there? Why have we never sent anything there? And so the agenda is now going to be what he just said, and that is, it's just not worth it.
This is hellish, but how bad is it really? Well, the average surface temperature is 471 degrees Celsius. Mercury is closer to the sun, but it tops out in the neighborhood of 430 degrees. Venus is hotter, thanks
to the atmospheric density and the pressure, as we'll discuss.
To its atmosphere. That atmosphere is made up mostly of carbon dioxide, so it traps tons and tons of heat. And the clouds are made of sulfuric acid, and those clouds do indeed rain. Meanwhile, the atmosphere is so thick that the surface pressure is a whole 90 times greater than Earth's, which would feel like
So, first off, how does a bus fuse react to that pressure? Second off, the electric universe theory. This is more to it.
Being almost a kilometer beneath the ocean, if that was something human beings could experience and survive. To make the comparison, we could try to engineer something akin to a deep-sea submersible to keep astronauts alive under the pressure of Venus's atmosphere, but that would still fall somewhere between very risky and certain death. Astronauts are brave, but they're also very smart. Smart enough that there's not a lot of motivation for human missions to Venus.
Smart enough to know you don't go past 230 miles up. Smart enough to know why.
What about robots? They don't need to breathe. The USSR actually sent not one or two, but 16 robots to Venus. This was the Venera project, in which a whole bunch of probes were sent to Venus in the 70s and 80s. They did send...
First thing I want to mention about that is, they were just probes in the exosphere theory. What is the first thing we're doing? Alright, so Marco Durante, Kate Rubins, everybody's working on figuring out how to genetically alter human cells to be able to stand heavier ionization. We're finding great technologies beyond our wildest dreams beyond that. I mean, the carbon ion therapy now is saving millions of people's lives. So, while we're searching for all of these technologies that can get us out there, we're recognizing simple truths like, oh, we can't have the molecular properties like Apollo had. That's why the tanks exploded at 1,000 miles up when it started to hit the first bands, and within the heavier F&E bands of the ionosphere, that is not something that we can take with. So Orion was sent up to not have it. So, after we learned all these simple things, we based it off of the ideas and the information that Russia was giving us and was using, because they make the first major steps. While we were trying to figure out if our computer systems would be able to, they knew what their computer systems would be able to do. And so instead of trying to genetically alter their human systems, because obviously, as they've been messing around with nuclear properties for much longer than we have, and have played with them in a greater state than we have, and fucked up as great as we have with them, we've all released about an equal amount into the atmosphere. Well, unfortunately, they've learned how to create the robots that can fly to space. It didn't do a good job docking, it needed a human assist, but this is just the first step. The next step is, after it's capable of docking, it's going to be capable of doing what the Apollo missions did when they had to get ready to go to the moon, or when they were hanging out in low Earth orbit for a while, and that is flip it around and connect it to their habitable station. So obviously that's the next step for the robot. And why would they do that? Because if we can create a system about 1,000 miles up where we weren't able to be and have not been able to actually obtain and sustain existence in, why this top height of the shuttle was 358 miles and why Apollo was 238, thus the Apollo Soyuz mission, the last time we flew men in the Apollo capsule into space. Yeah, we met him at 230 miles up, and that's where we're at because that's where we can go. This robot that Russia's just making, just like they were the first to make the probes to start studying everything, and then in the 90s we started making these probes to study everything exactly the same as they're talking about. And of course we're rovers too. Everything's just driving all over. Dune buggies on the moon. Propaganda exists everywhere. Russia has their propaganda. Jesus, we didn't even know about Anatoly Bogowski until he defected into the United States. That's when we learned what happens when a proton from a particle accelerator actually contacts human cells. And we know that it cuts like a bullet straight through you and then cauterizes everything as it goes through. Luckily, it's not radiant enough as it does that to kill you, and so his face was just paralyzed, like being shot in the face, but he survived it. Pretty much what you'd experience if you ever actually experience like 100 TeV heavy cosmic particle if you have no active shielding and we're flying around in space. Speed, power, all of these things are it won't take all of your cells, but it will take many of them. It will work its way through and stop somewhere. And who knows what it's going to take with it and what you'll die from because of that. So, inevitably we stop at 230 miles. Everything's from Telescope. This is them stating more proof to the robots that they're making today to go 1,000 miles up is because we can't go any higher than that. Everything is from probes, and the probes are just getting more and more advanced as time goes by, thus the new X-ray gamma communications systems.
Some good data back, but the absolute toughest of the landers,
CGI,
the 13, lasted a whole 127 minutes. That was
See, they have a picture of this, but you want to know why they chose not to use the actual released photo from the USSR? Because it looks just like Russia's landscaping, and everybody's pointed that out. Kind of like the moon landing kind of looks like southern Arizona, maybe parts of Nevada. There's mountains that are very similar, and the terrain is identical, and kind of like Mars. Sure looks like Atacama Desert down in Chile. These places, I mean, granted, celestial bodies are celestial bodies. However, it's interesting that we go to the places that will have identical properties, and so being at the North Pole with that type of terrain and the consistency of the skies, there's a good possibility that they could have made something that looked like it. However, today it's kind of hard to back that up, and so CGI is a much more apt thing to discuss, just not discussing old propaganda. That's why we redid all of the moon landing pictures, and we don't release any of the original footage. In fact, most of it's been lost, and but we found some new stuff. It's this new guy. He was like, a part of the crew, and he kept it safe forever. I mean, he never told anybody about it, just kind of found it, and here you go. Here's a bunch of new footage, and we redid it for you, so it's computer graphics are enhanced, and so now it's sharper and brighter and crisper, and you can see everything more clear. And so that's what we do with the old propaganda, and it's easier to just make CGI now instead of actually show the bullshit from the past, because, well, technology is assisting people in understanding that that's propaganda, and that's not how things actually work or would look.
Longer than its predicted lifespan of a half an hour, but still shorter than the shortest Harry Potter film, which is Deathly Hallows Part 2. We check. At that time, it was really impressive that humans were able to build something that could survive the conditions on Venus for longer than 30 minutes.
Exosphere.
It's still impressive today. And that's because
we're still in the exosphere trying to figure out basic communications and telescopic capabilities. Period.
machines have their limits too. If we think of a rover or a lander as a set of instruments contained in a single package, we don't just need the packaging to survive, but those instruments too. It's kind of like building a spacecraft for humans, actually. The outside needs to be strong enough to withstand the environment, and the inside needs to be hospitable to its inhabitants. Hypothetically, we could build a lander or a rover out of something that is primarily carbon, which has a melting point of 3,550 degrees Celsius, but that's just the body. The casing. Inside that casing, we need to create the pressure and temperature conditions necessary for computers and scientific instruments to function. And while we've made lots of advances in high-temperature computing, like innovating new heat-resistant materials for circuitry, we're not ready to put a computer on Venus for a long mission just yet. Essentially,
all of that completely disregarded the possibility that there is any ionization occurring there, and that it's not just harsh properties such as pressure or heat, but that the ionization is a secondary heat and also a consistent problem for things like bus fuses. There's no way that could operate in such a heavy ionic plasmic environment. So if any of this carbon is like a heavy alpha carbon particle, like GSI has shown in their environment, it will be heavy and it will be radiant, and there will be major complications to not only the equipment, but inside. If any of these particles were to be ionized, they could bond with any of the materials, causing the materials that we bring with to be ionized, and if we don't have shielding keeping that off, we'll be ionized. So there's all that they completely disregard because, well, even in our magnetospheric, in our bands, there are properties that make it possible for us to exist only at certain levels. So if ours is showing that up high we can't be because of the ionization, what's to say that Venus and the consolidation of all of that, the pressurization, hasn't caused the ionosphere all the way down to surface level?
We'd have to radically rethink and re-engineer everything we know about space rovers in order to send one to Venus. And the time, money, and energy it would take to do that is just not worth the results, and not really in line with NASA's current goals. Right now, we're big into astrobiology. We really want to unravel the origins of life and probe its limits.
So, that was a subtle reminder that Francis S. Collins, Kate Rubins, everybody, like I was stating, is working on trying to figure out how to genetically alter the human body so that we can take the heavier ionization within that turbulent plasma state. So, unless we can, as GSI's Marco Durante, as Princeton, as now Berkeley, as everybody has stated, you have to be like the Hulk. You have to be able to take and give gamma at a rate that we can't without succumbing to cancer, to be able to be out there. So, again, bioengineering, everything we've been talking about since, even Halo, is everything it has to do with this mindset that we know of and have known of since we touched space, and that's, to be like Stardust. If we want to go back to being like Stardust, as we came from Stardust to go back to being like Stardust, we have to become radiant. Captain Marvel. These are prime examples of it. You cannot actually be in that environment without being what that environment is made of. So, human engineering is absolutely NASA's #1 and top priority, because without it, we're never going to get off the planet more than Russia has taken us off the planet.
This one's had life on it before its seas boiled and the air became poison. Evidence of that life would be incredibly difficult to get to if it exists at all. That evidence would have to have survived billions of years of, Venus. And
there's no reason to think why it couldn't, because, we have found within our tubs and our gallons of radioactive, the Salton Sea, and we found it in pure mercury. So there is no disputing that life exists on Venus. It's just, what do we consider sentient life? What do we consider life as a standalone and not just as we're starting to look to, the possibility of sentience being within electric form, or the balance between molecular structures. So what's to say there's not a balance of molecular structures, and that energetic properties consist within it, causing what we're now starting to say is sentience, synapsis, thought. So
You can't get state-of-the-art technology to last longer than 2/3 of Avengers Endgame. Again, we checked. We don't have much chance of finding it in time. Space exploration is inherently risky, so exploration plans are very much about risk mitigation. And whatever interesting science might theoretically be on Venus, it's not worth investing huge amounts of energy on a mission so risky when there are other much less risky targets for exploration. Take Mars.
Take Mars. Well, fuck Mars, because aren't we talking about Venus because Venus is the example as to what Earth is going to be like because of climate change? So, clearly, there's an invested interest in climate change. Only a few fucking Republicans and some beat up fucking rednecks who don't understand the science of it all are disputing that climate change exists, that humans are driving it, that is going to happen whether we stop or not, and so we need to start to understand what we're assisting and what is the inevitable for us. So, obviously Mars is not a high priority when the priorities are climate change, when the priorities are trying to figure out how and why we can stop ourselves from becoming Venus. As we're starting to, that's what this video is all about, and that's why the money should, would, and is going to be invested once we decide that the propaganda wars are not worth it. It's all types of science fiction that's inevitably going to play true. Why Interstellar is such a good movie. Because inevitably, this shit right here is one step before the food wars. And then when smaller continents start warring over smaller shit, then we all start looking towards education. When we find that we failed, and we all tried to just start growing food and growing trees, and we actually focus on it, it'll be too late. This is the point in time when we should have spent educating ourselves to understand how it is we can either fuck off, prepare for fucking off, or fix our fuck-ups and not fuck off.
Mars, for example. Mars is very hard to get to, but it won't immediately break your machines when you get there. And every time...
The Atacama Desert is really hard to get to, but it won't always break you every time you get there. So it's a low risk, but high study mission. So every time we want to figure something out, say there's parts of Chile we can't really get to, or, well, it's not safe or habitable for humans to stay. So what's a good way to test our equipment? Well, if you needed to test heat shielding and parachutes, if you needed to test communications capabilities, if you needed to test the ability to weather radiation and low oxygen or low gravity, then you know what? The best thing you could do is launch from the equator of the Earth, let it go around a couple of times, and then launch from a high geosynchronous orbit, say like the mid-thermosphere, like 3,500 miles up or so, like where Orion started to be zipped out and losing communications, and then you would release it back to Earth, and then you would try to figure out if your trajectory could hit this one spot on Earth, and you'd survive. The heat shield have to make it through. It'd have to deploy perfectly. You'd have to have the shield, the parachutes open. It would have to deploy itself once landing. You would have to establish communications with it. All of these things. And, well, as we don't see this happening in military wars, you can safely say that obviously NASA is R&D for the military, and as soon as NASA perfects this, and the Mars rover and all of these things are actually capable and functional, then we're going to start dropping them all over the place. Why? Because they'll be capable of being launched as little microsats, and we'll have tiny individual little drones that we can drop all over the place and control via stations outside of Earth. That's why they're so afraid of 5G, is they're going to turn our systems off and then just fly around us with whatever the fuck they want. And they can drop in from wherever now, because if we don't establish a Space Force, as their fucking paranoia is all convinced, we're going to be dominated by them, and they can come out of nowhere. Because we've been using our R&D department, NASA, to figure out how to do suborbital launches to drop things back in and control them well in a different part of the Earth, all with GPS station communication satellites. So, with their technology now being better, we're starting to worry about whether or not A, they're going to start looking into places more like Venus, or if they're going to overtake us. And so, bottom line, all of these rovers and everything, They're nothing more than systems we have designed to practice here on Earth so that eventually, once we can leave the magnetosphere and we're not confined to the thermosphere and most of these amazing crafts to the exosphere, we'll be able to actually send them to these other celestial bodies. So,
When we go, we find new and exciting evidence for a once habitable red planet, like dry lake beds and extinct hot springs, and just that.
okay, first off, we've found that almost all the celestial bodies surrounding us in our solar system take and release water at a phenomenal rate. I mean, we're losing hydrogen, helium, and oxygen, and all these properties at a phenomenal rate. It's this nitrogen that's keeping most of it stuck in on us, followed by the carbon compounds. All of this is, well, climate change. And so, as we're learning why things give and take, we're understanding that Mars is actually picking up a great deal of water. The majority of water that's being ionized away from the inner rings, asteroids, and various anomalies, the sun itself, all of these properties will form and create water on that planet. So, those aren't riverbeds. They never were. If you take any acknowledgement to the fact that they are stating that it doesn't have a magnetosphere but is confined within the sun's magnetospheric bands, however, it's on the outer reaches, confined by a great deal of carbon properties that are ionized, however, within a negative space, without any potential magnetospheric properties, then obviously any rogue flybys or anything that could be a potential threat to it will create a static charge within this electric universe, this plasmic state that they're saying is all intertwined, as it's like the Earth is, a ball underwater, and there is an invisible shield keeping all the water off us, and we just get 1% of that little bit of dew that kind of comes in and then forms some dew around us from that little droplet that makes it through and kind of mists, atomizes within it. We get a little bit of that condensation. Well, Mars is just in that water, period. Absolutely soaked in all of it. There's no magnetosphere. So it is electronically charged. It is radiant because it is constantly ionized. Any celestial body, any of the bodies that are flying around in any of its little moons or anything, would cause polarity swaps and differences forming. What we're now learning about sprites happen here and all over, especially over on Jupiter and these places. It would cause lightning. It would cause severe sunburns, as we're starting to call it on the moon. It's not active water beds. Those are sunspots from active fields of polarity swap and the burn from the radiation, from the heavy ionization from solar energetic particles, causing it to pretty much create a spark. Whenever the polarity flips, there's a neutral point that happens and it causes a spark, and that spark will shoot the ground. It'll fry it. You can do this with wood. If you use electricity on a lot of things, you can actually create the exact same structures that you see on Mars with the electricity here on Earth by creating the polarity differences within these carbon structures. So, it's obviously not a previous Earth. It's going to become an Earth. It is through the poles, specifically the North Pole that we can see, it is gathering and pulling in through those polar cusp points, as we talk about where we get our 1% of the 1%. It is gathering these things, and potentially, as water is formed, as we've shown from Nottingham University and lots of other prestigious universities have pointed out, magnetospheric properties exist within gravitational points that exist because of molecular structures. That's why we are confined, as gravity has us placed, by our molecular structures. We leave the mesosphere, we're in microgravity. We go too far down, we're crushed because of the gravitational centering. We're pushed back up, just like we're pushed back down. At certain points, we are forced into our molecular structure's positioning. And that is what gravity is for each individual point and every single element within space. All of them are bound by their own state of relativity. Their gravitational center only exists through their properties' reactions to the surrounding properties. So, there might be soon.
As Mars is a field of more great targets. Asteroids. There's a lot we want to look into there, from water
That's why the
to chemicals
robots.
similar to ones used for life on Earth. And
Asteroids come much closer than the moon. Asteroids dip within the magnetosphere. Asteroids come within the exosphere many times. So, while we're talking about these far-field dreams of reaching celestial bodies in the outside world and way out of our magnetosphere property, we're actually looking towards figuring out how to genuinely land, or at least hit or touch, thus mine, all of the asteroids that we are just now noticing there are a lot more of, as they're starting to fly over our head in Russia and places like that, and force us to acknowledge.
The asteroids are comparatively easy to explore. You can't have acid rain if you don't have an atmosphere. So yes, Venus is metal as heck, but that's precisely why it's not a good target. It's too metal for us, or rather, we are not metal enough for it.
So, again, the driving point that they are going to make constantly, Neil, SciShow, Space.com, all of these places are making only one point, and that is, man, it's just not worth it. We know everything we need. Stop asking why. Let's just check out this cool stuff we've done. Mars, man. Mars, Mars, Mars. See, we don't need to talk about gravity, Neil says. We've gone to Mars. We know all about Mars. We don't need to talk about Venus, he says. We've gone to Mars. Mars, Mars, Mars. Don't forget, don't remember that, the moon, we still have to get there. But Elon Musk says Mars. Neil talks about it. Everyone's talking about it. Shit, the Planetary Society is going to make us sails, and we can sail our way to Mars.
Yet. By now, we're extending our search for life far beyond our solar system. And if you enjoy learning about how to look for habitable planets, you might enjoy Living Universe, a Curiosity Stream original. Living Universe explores how we can identify and explore potentially habitable worlds in other solar systems.
This is gross.
And it's just one of over 2,400 documentaries and non-fiction titles
you have to be paid
on Curiosity Stream. Topics include space, which you might like since you're watching SciShow Space, but also nature, history, lifestyle.
That's all it's about.
Right now, you can get unlimited access starting at just $2.99 a month.
Paying up.
For SciShow viewers, the first 31 days are completely free.
$2.95 a month. Dude, to talk about what everyone's talking about. That's what's fucking wrong with all of this. So, with that, I end it here. This is all propaganda. More propaganda.